An equation that contains a trig function is called a trigonometric equation. In this section and the next, we'll be looking at how to find solutions to these types of equations. In section 7.4, we'll be looking at more basic fundamental trigonometric equations, and then in 7.5, we'll be looking at how to find the solutions to trigonometric equations that require us to use either identities or formulas. Before we look at any problems, let's go ahead and recall the period of sine, cosine, and tan. Sine and cosine have the same period, and this is given by 2 pi. And recall what this means. This means that if we evaluate sine at theta, and if we evaluate sine at theta plus some multiple of 2 pi, then they're going to be equal to the same thing. And this definition also holds true for cosine. Now, tan has a period of pi, which means that the values of tan repeats itself after every multiple of pi. Now, this fact is going to help us find all solutions to a trigonometric equation. And the way we're going to do this is we're going to find one particular solution. Then, since our trig functions are periodic, we'll get an infinite number of different solutions depending on the period. Let's go ahead and look at an example of this. Here we want to solve the trig equation cosine of theta is equal to 1 divided by 2. And we're going to break this up into two separate steps. In the first step, we're going to find all solutions in the interval between 0 and 2 pi. Then, afterwards, we're going to find all solutions. For step number 1, let's first start off by sketching a picture of our cosine on the interval between 0 and 2 pi. The graph of cosine on this interval looks something like this. And what we notice is that it appears our graph contains two y values at 1/2. And this tells us that we should have approximately 2 solutions on this interval. We can go ahead and confirm this by looking at our unit circle / right triangle interpretation. The first thing we notice is that we can form a right triangle in quadrant 1 with angle theta here, whose adjacent side has length 1 and whose hypotenuse has length 2. Then let's go ahead and write out the following. And this again tells us that in the first quadrant, all trig functions are positive. In the second quadrant, only sine's positive. In the third quadrant, only tan's positive. And in the fourth quadrant, only cosine's positive. This means that we're going to have another solution in the fourth quadrant, whose reference angle is given by theta. So let's first go ahead and find theta. We see that the opposite side of our angle theta on our right triangle should have square roots of 3. This tells us that theta is going to be equal to pi divided by 3. Now to determine what theta 1 is, we need to go ahead and subtract a reference angle from 2 pi. Theta 1 in this case is going to be equal to 2 pi minus pi divided by 3. This is going to be equal to of 5 pi divided by 3. And these are our two solutions. Either theta is going to be equal to pi divided by 3, or we'll have another solution at 5 pi divided by 3. And we're done with step number 1. Let's go ahead and look at step number 2. And we want to find all solutions to the trig equation cosine of theta is equal to 1/2. And recall that we reviewed the period of cosine theta is given by 2 pi. And what this tells us is that theta, which is equal to pi divided by 3, is a solution. And to find all other solutions associated to pi divided by 3, we're just going to add a plus 2 pi times k to it. And we'll do the same thing for our theta 1. This is again equal to 5 pi divided by 3. And we just add our 2 pi times k. And these are going to be all possible solutions of our trigonometric equation. This problem highlights the general process of how to find solutions to trigonometric equations. First, we find the particular solutions in a given interval, and then we find all solutions by adding the correct multiple of pi to our particular solutions. Let's continue to practice this idea. In this problem, we want to solve 2 cosine of theta minus 3 is equal to a negative 5. This time, we want to start off by isolating our cosine theta. So first, add a 3 to both sides. This gives us 2 cosine of theta is going to be equal to a negative 2. Then divide both sides by 2, and we're left with a cosine theta is equal to a negative 1. Now, let's sketch a picture of our cosine theta again on the interval between 0 and 2 pi. Our graph will look something like this, and we see that in this interval, our cosine theta only achieves negative 1 at one value here. This means on the interval between 0 and 2 pi, we should only have one solution. And to find the solution, again, let's go ahead and just draw a picture of our unit circle. So here's our unit circle. And recall that a point on our unit circle, xy, is actually equal to either cosine theta or sine theta. And this means that at the point negative 1, 0, we have that this is equal to a cosine theta sine theta, and we have our solution. Theta must be equal to pi. So now that we found our solution on the interval between 0 and 2 pi, we need to go ahead and find all other solutions. Again, all solutions to this equation are going to be given by pi plus some 2 pi multiple. Therefore, the general solution of cosine theta is equal to negative 1 is given by the following. This is going to be pi plus 2 pi k is equal to theta.